In this video, we are going to look at where a function is discontinuous. It wants us to find all values where the function is discontinuous. And for each such value, it wants us to define what f of a is and the limit as x approaches a for f of x, or state that it does not exist. So since our function here is f of x equals 7 minus 3x, which is all over the quantity 1 minus x, and that quantity is times 3 plus x in the denominator. We have a rational function, and so we need to be worried about values which set our denominator equals 0. So it's undefined at these values, and so this is where it's going to be discontinuous. And so looking at our first factor in our denominator, 1 minus x, we want to know when is this equal to 0? And so this is when x is equal to 1. So if we added x on both sides of the equation, we get 1 equals x, or x is equal to 1. We also want to look at our other factor in the denominator, 3 plus x, and we want to also look at when is this equal to 0. And so if we subtract negative 3, or we subtract 3 on both sides, we get x is equal to negative 3. If these values set our numerator also equal to 0, these will be where we would have holes on our graph. But these numbers don't also set our numerator equal to 0. And so these are actually vertical asymptotes on our graph of f of x. And since those are vertical asymptotes, our graph never touches a vertical asymptote. It just gets closer and closer to it as it shoots off to positive or negative infinity. So it wanted us to find f of a at each one of these values. Well, f of 1, like I mentioned, that makes our denominator equal to 0, so it's undefined. This does not exist. Same thing with f of negative 3. This sets our denominator equal to 0, so it does not exist. If I'm looking at the limit, though, as x is approaching 1 of this f of x, 7 minus 3x, all over the quantity 1 minus x, all times 3 plus x. I know the limit doesn't exist, but sometimes we want to know, is that limit shooting off to positive infinity or negative infinity? So let's look at what's happening if we put in values. If we look at the limit coming in on the left-hand side. If we're coming in on the left-hand side, I'm choosing numbers which are close to 1, but are less than 1. So for example, 0.9 or 0.99. So I can get really, really close to 1 on the left-hand side, but never approach it. So let's think about positive and negatives. If I plugged in a number which was less than 1, and wherever I see an x, I want to know, would my result back be a positive number or a negative number? And this would tell me, is this shooting off to positive infinity or negative infinity? And so if I plugged in something smaller than 1, 7 minus 3 times something a little smaller than 1, that's not going to get me up to 7 to be a negative number, or less or more than that. So this is going to be a positive number in my numerator. All over, well, 1 minus something less than 1, so 1 minus like 0.9, that's positive. And then 3 plus a number less than 1, but close to 1, would also be positive. So this tells me as x is approaching 1 on the left-hand side, my vertical asymptote is going to shoot off to positive infinity. I also want to see what's happening as we come into x equals 1 on the right-hand side. So now when I'm plugging in numbers, I'm plugging in numbers bigger than 1, but close to 1. I'm going to do the same sort of reasoning to see, is my result coming back positive or negative? So again, if I plug in a number close to 1, multiply it by negative 3, that negative number is not going to be bigger than 7. And so my numerator would be positive. All over, well, if I plug in a number like 1.1 and I look at 1 minus 1.1, that result is negative. times 1 plus, like 1.1 is positive. So I see as x is approaching 1 on the right-hand side that this function is going off to negative infinity. So we can do the exact same thing for the limit as x is approaching -3. Again, there's a vertical asymptote there, so the limit doesn't exist. But sometimes, again, we want to see what's going on with the graph. So let's look at x is approaching -3 on the left. And let's see if we plugged in a number in for x that's less than -3. So -3.1, -3.01, -3.0001. So those are numbers that are less than -3. And we want to know if we plug in that result, are we going to get back a positive or a negative number? Well, if I look at -3 and I plug it in here, well, -3 times -3 is 9. 9 plus 7 is going to be positive. It's going to be a little bit bigger than 9. So -3, if I plugged it in for x here, 1 minus a -3. Well, 1 plus 3, that's positive. And then if I plug in a -3 into this factor, well, a little bit less than -3, so -3.1. 3 plus -3.1, that actually gives me a negative result. So I see I have a positive number in the numerator, a negative result in the denominator. So I can see that as x is going to -3 on the left-hand side, this is shooting down to negative infinity. So let's do the same sort of reasoning one more time, but now let's look at the limit as x is approaching -3 on the right-hand side. So since I'm approaching -3 on the right-hand side, I'm choosing numbers that are bigger than -3, but close to -3 on the right. So like -2.9, -2.99, -2.999. So I'm going to do the same sort of reasoning, and I'm going to plug in a value close to -3 on the right in for x, and I want to see if my results is going to be a positive or negative number. Well, if I plugged in -2.99 and multiplied it by that -3 in front in the numerator, that would be positive number plus 7. So this result would be positive. If I plugged in -2.9 here, I'd have 1 minus a negative. So that's really 1 plus the 2.9. That is also positive. And then if I plug in -2.9 in for x for the second factor in the denominator, 3 plus a -2.9, and that is also positive. So I can see that as x is approaching -3 on the right-hand side, that this is going to positive infinity. So again, as our limits are shooting off to positive or negative infinity, they don't exist. But a lot of times, again, we want to know what's going on with the graph there. And so we can see what's happening on the left and the right-hand side of our asymptotes, vertical asymptotes, by kind of thinking, would my result be positive or negative when I plug in numbers close on the left and right of the value where our vertical asymptote is. So hopefully this was helpful for you.